Section 3, we're going to look about nth roots and radical exponents. So when we talk about roots, like we have square root, right? So it looks like this. We have cube roots, we have fourth roots, fifth roots, and it keeps on going, right? It keeps on going. That's what this n stands for, just any number you can plug in there. So normally we don't plug in a 2 for square root, right? But any other number we plug in, right? So that is actually called the index. It's in between this radical sign, this little check mark part right there. This right here is the radical symbol. So this right here is the radical symbol, and whatever number or anything that's underneath the square root is called the radicand. Now what we can do is we can turn any radical square root into an exponent. Okay, so like if I have the square root of 36, I can turn that into 36 raised to a half power. So that's where we get this rational exponents as a fraction, fractional exponents. So cube roots, say cube root of 36 would be 36 raised to the 1/3, right? A fourth root would be 36 raised to the 1/4, meaning what times itself 4 times is 36. Okay, and anytime we have a even one, anytime we have an even one, like squared, like to the 4th, to the 6th, any of those ones will always get a plus and a minus. Oops, a plus and a minus. But any odd ones are just going to be regular. So whatever the radicand is a positive cube root of 36, then my answer just will be negative or positive. If I have any odd, say it's negative fifth root of negative 36, then my answer will be negative, right? So whatever the sign of the radicand is on any odd root or index, then it will be whatever that number is, positive or negative. Okay, and then also whatever the index is, that is the denominator. So as you can see, it's 1/3, 1/2, 1/4, negative 36 parenthesis here because that negative in there, so I'd do a parenthesis around that, and then 1/5. So the denominator of my rational exponent, my fraction as an exponent, is always the index, the type of root. Now if I was to raise this to a power, say square it, that would be the numerator. So it could be on the outside like that, or it could be on the inside. So this is the 4th root of 36 cubed. That would be in the numerator. So any power either on the radicand or on the outside would be in the numerator. And that's how rational exponents work and how they can turn into radical exponents work, radical expressions work, and how they turn into rational exponents. So they are simplified when the radicand contains no fractions. So we want no fractions in here and no radical appears in the denominator. Okay, so for example, we don't want to have a problem like 1 over square root of 2. So we have to rationalize that. So we get root 2 over 2. So then if we have a radical of a fraction, this would break down to the radical of the top over the radical of the bottom. So we get 1 over square root 2, and then we can't have a radical on bottom. So like we rationalize the one above, root 2 over 2. So square root of 1/2 is root 2 over 2. So radicals contain no fractions, so I can't take the square root of a fraction. I can just separate the fraction on the top over the fraction on the bottom, and then I can't have a radical on the bottom though, so I have to rationalize it. Okay, so that's basically the idea behind 4.3, is turning roots into rational exponents, where radicand is the base and the index is the denominator. So if I have the nth root of, say, any number, say a, raised to a power, I can rewrite that as a as the base, m in the numerator, and n in the denominator. And this is an exponent. So that's the idea behind 4.3, nth roots and rational exponents.